All right, ladies and gentlemen, we're going to continue this morning's physical properties and boiling point predictions video. There was an error at the end of this morning's video. The introduction stays the same. Same story. In the morning video, I said that all of these were C9H20 or equivalent in terms of math. I was wrong. A student correctly pointed out that this first one's actually C11H24. That means of the 3 molecules or 4 molecules here that have London forces only, the bigger one is always going to be higher in terms of its melting point or boiling point. Either one. This is a boiling point question. Let's only talk about boiling point. So I moved A. This morning it was over here because I thought it had the same formula and a lot of branching. And that would have put it first, but it didn't have. So I took it off and put it at the end. And then we talked about branching in class, you and I together just now. In the morning, we had a nice discussion about branching, so I'm not going to repeat that part with the pieces of paper folded and flat. You remember that, right? That's where we made our distinction between B and C. Same formula, same intermolecular forces. You have to have both of those things before you even talk about branching ever. Notice my discussion does not just talk about branching of A. Here's my discussion. Higher mass than CHB. Therefore, higher London forces. And I may have lost a couple students when I used the word therefore, and there's this funny symbol there for therefore that you may not have seen. The 3 dots forming what looks like a triangle. It's a math thing. It means therefore. It's a nice short form. I like it. You can use it on tests. Okay? So your discussion has to talk about these having London only. Your discussion has to say that, it doesn't yet, but it's going to. Branching lowers London compared to H and B. H and B. H and B. Okay? So, intermolecular forces again. The hydrogen bonders. The category was, because these will be our best ones, right? The hydrogen bonders are all down here. Categories 3 and 4. I do want to point out that a carboxylic acid, this is a carboxylic acid, is better than an alcohol because it can hydrogen bond to another carboxylic acid this way, and it can hydrogen bond to another carboxylic acid this way, and it can hydrogen bond to another carboxylic acid this way. You can't do that much with alcohols because it can only hydrogen bond this way to another alcohol or this way to another alcohol. That's less ways. This carboxylic acid could go 3 ways, right? Alcohol goes 2. So if you have to choose between a similarly sized alcohol and carboxylic acid, which one is going to be top dog? Number 1, carboxylic acid. Good. So I think we do have 1 carboxylic acid, and we'll just throw it at the end of our list, right? Isn't that the only carboxylic acid? E. So when we're done, E at the end. Most, and here's your explanation, most extensive H bonding. Good? There's another 2 that have hydrogen bonding. There's C and D. Okay? C and D. What functional group is C? Yeah, it's a primary amine. Yeah. And D is an alcohol. I didn't write that. Alcohol. And ladies and gentlemen, it's not even close. The electronegativity of oxygen is a lot higher, 3.5 versus 3.0. So I know the amine, you're tempted to say, there's got to be more hydrogen bonding for the amine. It's got two H's that can hydrogen bind. You can think that, that's a good thought. But each of those hydrogen bonds is less than half the strength of any alcohol hydrogen bond. I promise. Much less. So it's not even close, folks. Any alcohol is going to beat any amine. Period. And all you have to do is say stronger H bonding than an amine. D is the second best. D, and the amine would be third best. Is the amine C? We have two C's. I got to change one of the C's, ladies. You notice that? I just confused myself some more. I'm going to go to the letter I for the amine. I know it's out of order now. Please fix yours too. I have two C's. I. And just tell me that of these two, alcohol, stronger H bonding than amines. I mean, I could ask for more detail, but that's enough. It's based on electronegativity. You know that, right? And I think we're running out of molecules. We've got a ketone and an ether to go and an aldehyde. The last three, F, G, H. Oh, we got the ether covered. F and G. That's it. We got them drawn, except for the aldehyde. Aldehyde's here. One student got tripped up, as I promised. What happened? They see CHO and they start thinking hydrogen bonding. They did. Honest mistake, but guys, you got to get over it. That H is not bonded to the O, is it? Do not talk to me about hydrogen bonding when H is not bonded to O. 1, 2, 3, 4, 5, 6, 7, 8. I got one more. They look pretty similar in terms of, you know, they're polar. That's why they're dipole-dipole. Delta plus, delta minus, delta plus, delta minus. There's a picture representing that at the top of the screen. Carbonyls are polar because of the difference in electronegativities. So why am I liking F a little better than G? They have the same mass, unless I messed up. I mean, I hope I did. They have the same mass, same formula, same number of carbonyls, but I'm liking F a little higher than G in terms of boiling point. F, I like how she said that. G appears to be a little more branched, right? It's not just a line of atoms, is it? And F is, I'm going to use your word, I'm going to use your thought process for my explanation. F less, oh, how about F more linear? I kind of combined yours with mine. You said F's less branched, and another way to say that, it's more linear, right? Which means stronger London. F more linear. Linear. Higher. London goes up. I'm not a stickler for using English. Symbols are very good in science. That is a sentence to me. F is more linear than G. It's implied because I got the comparison between F and G with that squiggle. Therefore, the London went up, or caused the London to go up. How's that for words? That should actually help some of our students who are English is not your first language. This is better, right? So I know that it's not great wording and stuff, but there's all the details I need are in this answer now. And we caught this morning's mistake. And I'm feeling a little better. I'm gonna stop the share.